Artificial intelligence has become ubiquitous. We only have to do a search, and any one of these engines will make a huge use of AI services. And I was thinking, how can they help me in my standard job of requirements development? In other words, what I wanted to ask, the question was, can Alexa make estimates, agile estimates? That's what I'm going to try and show. The agile estimation process, it's simple. We start off with capturing the user need in user stories. We're going to size those user stories as function points, and then using benchmarks to make estimates. Keep it simple. The attributes, though, of the estimate are key and crucial. So I think you've got to have a precise estimate. And for me, precision is a function of completeness, because if you've missed out a user story, you're going to have an imprecise estimate. But also, you want your attribute of accuracy. You want that estimate to be accurate, and this, for me, is a function of correctness. If your user story is incorrectly expressed, then the estimate is going to be inaccurate. And finally, you want that estimate to be repeatable. And repeatability, for me, is about consistency. Because if a user story uses inconsistent terms, then different estimators will make different assumptions, and we're going to get a different result. It's not going to be repeatable. So those are the things I'm going to aim for. I want it to be precise, accurate, and repeatable. And for that, it needs to be complete, correct, and consistent. So the AI technique that I'm going to use is natural language processing. We're going to use that technique to look at our user stories. Now, how do we do this? To look for correctness, we can do textual analysis, we can do syntax analysis and semantic analysis. If we're going to look at completeness, well, you can't do completeness. You can only look at how incomplete it is against the standard. So incompleteness, for example, you want to make sure that you've got a create, a read, an update, and a delete function to all your data groups. And you can look at incompleteness between functions, between high-level goals, lower-level requirements, lower-level user stories. And then for consistency, we want to make sure we don't have duplicate or redundant user stories. And we also want to make sure that when we use a particular term, we use it to mean the same thing throughout. So those are the natural language processing tests, if you like, that we're going to use. So let's look at textual analysis. This is really boring, because I collect bad statements of user need. These are actual things I've seen in requirement specs in user stories. And it's easy. We can all spot what is going wrong, because there are words and phrases, constructs, which we know to avoid. And in red, I love the one, appropriate standards will be used when necessary. I just think that's just meaningless. So we can then run some metrics. I love numbers. I'm a numbers person. And so I can calculate how many words to change, and then I can set up a text quality metric. And this is the number of words that I have to change in each one, and I'm going to call them low, medium, and high. And so I can have a lovely a table. Look at that lovely table. Look, 19 things, average of 3.8. I can sort of say, well, it takes me about 10 seconds to change a word. I sort of get some feeling on what's going on. So that's easy. This is 40 years old technology. I am that old. I remember Fortran 77, and it had text analysis on it, and great it was. The next step was syntax. Now, the syntax of a user story. Here's a couple of pretty well-formed ones. As an author of user stories, I want to maintain high-quality user stories. Well, if you look at good, well-phrased user stories, you can find a pattern. They start with a thing called, we'll call it an actor. Who's doing it? Then we have an imperative. I want to do something. I have to do something. I need, or I shall. Then an action, what you're going to do. I'm going to maintain, or I might list. And then the object that we're going to perform that function on, possibly with a constraint. So there is this pattern that we can use. And this is well known. This is only 20 years old. This was the paper that I read that really made that light bulb moment come alive in my head, that you've got all these various elements and syntax of a well-phrased statement of value. So, syntax for user stories. This is the one I happen to use. As an actor, I want to do something on a particular object, on or with some indirect object, with a target, maybe with an event to trigger us, and eventually the very important thing at the bottom, so that the rationale. Why is it we want this user story? What is the value that we're going to deliver as a result of implementing it? So that's the syntax for user stories. And this uniform syntax, I've found, increases clarity, consistency, and completeness, but it doesn't solve the correctness problem. So let's have a look at an example. As a library user, I want to search for books in the library catalogue on a computer screen with speed and ease of use when I provide a book title, even if the title is incomplete, so that I can, delivered value, find all the books of similar titles. Now, some people don't like user stories. Some people prefer use cases. I don't mind. All you do is you rearrange the items within the syntax, and you have an example of a use case. I provide a book title and begin a search for books in the library catalogue, on the computer screen, even the book title is incomplete, so that I can find all books of similar title. I don't mind. Doesn't bother me, as long as I've got the important bits, the triggers, the actors, the actions, the objects, etc. Within that expression, we can work with it. So, we can do manual syntax analysis. At the beginning, it's who is doing it and what is being done. We then move into when it happens and how, and we finish up with the why. Very simple, that's the syntax of that user story, that pattern that I use. Next is semantics. 3 words, book, library. Any 3 things can be in a combination of 6 different things, orders, but only 3 of them make actual syntactic sense, and that is a library book, a book library, and book a library. And I've used the word book in 3 different ways. It's an object, because that's what I want. I'm looking for books. But also, it can be a descriptor. It's a type of library. Or it can be an action. I want to book the library. So we've got a problem here. And I can show that it's the difference, if you like, or the comparison between correctness and consistency. Here's the first 3. They are syntactically correct, but 2 are, for me, are semantically wrong because I'm using the wrong meaning of that word book. Here are the 3 others. They are all syntactically incorrect. One of them is both syntactically and semantically incorrect. And then we have the wonderful user story. I want a book from the book library. Now, the key element here, and this is the first take-home, the first take-home is that the book from the book library is syntactically correct, but semantically wrong. In other words, it's not a matter of just doing textual analysis and syntax analysis. We have to do semantic analysis as well to ensure that we have a well-formed user story. What we really should have said, I want to reserve the book from the document library. That's the introduction over. Here's the strategy for the estimation. I'm going to use natural language processing to identify users in the user story, processes in the user story, and to identify the entities in those user stories. Then we're going to use the correctness, completeness, and consistency analysis to check whether or not we're making any sense. And this will allow then a functional size to be calculated, and from that functional size, we get the estimates that we want to make. That's the strategy. So how do I identify users? There's all sorts of types of users, normal users, maintenance, support, but also other bits of software, other operating systems, all those sort of things, and of course hardware. You might have a real-time clock involved in it. So there's lots of different users. Well, how do I identify them? Well, at the very beginning, it's the subject of the sentence, as a, and there's my user. So that's quite easy to find the users. Now I need to identify processes. Well, first of all, I need to define what a process is. It's when one of the users, be human or otherwise, passes data into a process. That process can be a data process, a transactional or a functional process, and then it will also access storage information and process. So here we go. As a user, I enter a search term. The search term goes into the search function, which takes data out of the catalog, and anything that match is off to the user. That's the process. And there it is. It's the verb in that first line. So we found our processes. We now need to, you're probably ahead of me, where are the entities? Well, it's not just a search term, it's a book search term. It's not a book, it's not a catalog, it's a book catalog. And we give book data out. So there are our entities, they're there in front of us. And it's just the object at the top, in the first part. So we've now identified the subject, the verb, and the object. So our strategy subtly changes. It's not identifying users, processes, and entities. We're going to identify subjects, verbs, and objects using our natural language processing. Then we can do the correctness, completeness, and consistency checks. Well, what are they? Well, the solution to those is simple. For correctness, we're going to say, well, has every user story at least one user, one process, one entity, a subject, a verb, and an object? Believe me, I've seen user stories without any verbs in them. It seems amazing, but it happens. So that's how we're going to look for correctness. For the consistency, have the users been named consistently? Have the processes and also the entities all been named consistently? And so often they're not. They're given different names like the user, or the invoker, or lots of different words. So we're going to make sure that we have a consistent set of users, processes, and entities. And for completeness, first of all, has every user been the subject of a user story, which is important? And then does every entity have a create, a read, an update, and a delete? So those are the checks that we're going to look at. So it's dead simple. We could do this manually. I don't need a computer to do this. There's the subject, there's the verb, the object. This is just one thing. But when I put it into my natural language analyzer, and I'm using a particular tool here called Scope Master, there are other NLP processing applications, but I happen to use this one. And there, right at the middle, it's found the verb. Excellent. Well happy. What else has it found? It's found some data movements. This is good. It also draws a pretty little sequence diagram, very nice. But at the top there, it's also found a user and an object. And when we go and look at those, we find that they found the right things. So it's working for me. Excellent. But it's correct, it's correct and consistent, but it's incomplete. And it's telling me that, yes, you're searching for stuff, but where's the user story for actually putting books information in that catalog? What happens if that catalog data is wrong? Where's the change? And what happens if the book gets lost? How do we delete it out of the catalog? Obviously, it's only one user story, so I really need to look at an epic. So I went to this. I went to the Scrum Alliance website, because they've published all the user stories that they used for their website. And I thought, I'll grab those, and I'll analyze those to see how good the Scrum Alliance are at writing user stories. Now, they do have a caveat. They do say this was their first attempt, and they know it wasn't particularly good. But anyway, this is an example. So how long do you think it would take to come up with a decent estimate of those, and also that's complete, consistent, repeatable, accurate? Well, this is how long it took me. I uploaded the 14 user stories, and it took me 15 minutes. I was having a bad day. The analysis took 6 seconds. The results came out. It found 14 of them. That's good. And it's estimated the total number of function points. It's got some quality and value of analysis figures. But anyway, I've got them in. And then it gave an estimate. And it told me it's going to cost about $53,000 to create this. and it's going to take about 3.5 months to do. Now, there is a big health warning on this estimate. The health warning is that I'm using industry standard benchmark data. And I found that it's always been wrong for my teams. My teams are always unique. I bet all your teams are also unique, so that you need to build up your own velocity profiles for your teams. But this is just to illustrate the point that you can then take that into an estimate. So let's have a look in detail. Everything was looking good. There's a problem here, number 7. It says there's 6 function points there. Well, I had a look at it, and it turns out that it has found 2 functions. And those 2 functions are to list classes and find courses. And where did that find courses come from? Oh, it is. But if we look, I've got a laser pointer here, I think. It's in the so that part. So the problem is I haven't separated the functional part from the non-functional part, as I showed at that beginning syntactic analysis. So I need to separate those out. So that's what I did. Version 2. It took me about 10 minutes, slightly better day, to split those non-functional and functional parts out of the user stories. We did the analysis. We got a whole set of results. That's lovely. It then did some estimates. Lovely. Same health warning. These are industry standard, and don't quote me on this. So let's look at the difference that occurred between version 1 and version 2. Well, the first thing to look at is that we found 17 users to begin with, and 46 objects were down to 8 users and 25 objects, because we've moved out of all that other contextual, really important non-functional stuff out of the purely functional part of the user story. Also, we've got an estimate of the total number of function points, and there's a quality score associated with what I've done. My quality score's gone up. Excellent. Let's have a look at them all. Yeah, things are looking better, but number 1 is a problem. It can't actually analyze number 1. And this is number 1. And it says, as a site member, I want to describe myself on my page. But this is supposed to be about profiles. This happens to be the very first one, and I think possibly the writer of this user story forgot what they were supposed to be writing about. So I thought, well, it's very simple. We just need to make it simpler. It's not about describing myself on my own page. I want to create a profile. This is where the description of myself on a page is a synonym for user profile. So it actually suggested and told me they couldn't find any suitable verbs, so I changed it. I simply said, as a site member, I want to edit my profile. That's what I think the real user story should have been in the first place. So what did I have to do? I had to reword 6 of those user stories. It took me 12 minutes. I did the analysis. Things are getting better. The number of quality defects have reduced. So here's the comparison between version 2 and version 3. So the users has dropped from 8 to 7, objects from 25 down to 10, quality scores gone up. But there's a bit of a, I can't remember my next page. Yes, quality has improved. So it started off about a 59% quality. I'm up around 74% quality. This is looking good. Quality has improved, but if we look at the number of items, that was my joke. Start again. Quality's improved, but, and it's a big but, defects were unmasked. Now, this is really, really interesting. It's the second take-home, which is, you know when you're programming, you run it through your syntax checker, and it says, you've missed a bracket there, you've missed a brace there. The little stuff you get rid of quickly. But you know what? That unmasks deeper problems in the code. And exactly the same happens here. Fixing those quick stuff there and then meant that I actually unmasked some underlying problems. The problems were here in the number of missing user stories. And it identified a whole bunch of objects and what's missing. And we can see at the top that I've got an application, and it's possibly a duplication, and there's the the whole lot's missing. You can't find a create, a read, an update, or a delete. Something's wrong. So what have I missed? So remember that these may also, of course, be covered in other epics, because that was only the first page. There was about a whole bunch of pages. There were actually 5 more pages, probably another 14 user stories per page, total of 70 user stories. Oh, I've got to analyze that log. How long is that going to take? Well, the result is simple. It took 15 minutes for the first one, 10 for the next, 12 for the next, and out of that, I've got 37 minutes to get 14 user stories. So maybe it's going to take another 3.5 hours to look at the rest of the 70, but I might find that actually all those stuff is filled in, or it may uncover a whole load of defects which I don't know about. So to summarize, I had 14 correct, consistent user stories, and it only took me 37 minutes. They're precise. All user stories were sized. It's accurate because the same size for each for the same function. It's repeatable. You can export the stuff out as a CSV, import it back in. Guess what? You get exactly the same answer. So I've got precise, accurate, and repeatable, but it's not yet complete. About 3.5 hours, therefore, to estimate all 70. Oh, that's a lot of work. Could Alexa help? Here comes the live demo. Computer, start cosmic functional size.
To add a user story, say add story. To add a functional user, say add user. To add a functional process, say add process. Or to add a data group, say add data.
Add story.
What is the name of the functional user?
User.
I heard user. Now what is the functional process?
Manage.
I heard manage. Now what is the data group?
My profile.
I heard my profile. The user story is, as a user I want to manage my profile. Shall I add this story to the list of stories?
Yes.
I have added user manage my profile to the list of stories and 13 function points to the total. Add task, add a user, add a process, add data, or calculate total.
Calculate total.
The current total is 13 function points. Add task, add a user, add a process, add data, or calculate total.
Add story.
What is the name of the functional user?
Manager.
I heard manager. Now what is the functional process?
Delete.
I heard delete. Now what is the data group?
Profiles.
I heard profiles. The user story is, as a manager I want to delete profiles. Shall I add this story to the list of stories?
Yes.
I have added manager delete profiles to the list of stories and 3 function points to the total. Add task, add a user, add a process, add data, or calculate total.
Calculate total.
The current total is 16 function points. Add task, add a user, add a process, add data, or calculate total.
Goodbye.
Goodbye.
Oh, it worked. So, thank you. Too kind, too kind. So there's voice recognition, which is a key important part of in artificial intelligence. Recognizing the story, then putting it in through the analysis and coming up with a function point. And if you know your velocity, you can probably have a time and effort. So, conclusions. Text and syntax analysis is not enough. Semantic analysis is needed, as you saw, book from book library. Correctness and consistency is not enough. You've got to have completeness as well. And very, very importantly, as quality increased, masked defects were uncovered. And I think that was the key take home for me was to discover those things that were missing. Recommendations. Committing to a sprint with an incorrect, inconsistent, or incomplete set of user stories may be agile, but it certainly isn't lean. The lean principle of waste reduction, which is what I see in a lot of teams, needs to be employed, and there are AI techniques that are available to help. Thank you very much for your attention.